How's it going, everyone? This is going to be the first video of the first lesson in our measurement unit. And this one is all about something called rates, where we're going to compare rates and interpret rates. So first, what is a rate? A rate is a ratio. A ratio is like two numbers, usually there's a top and a bottom number. It's written as a fraction. A rate is a ratio that compares two quantities that have different units. So for example, say you want to fill up your gas tank if you drive a car. Well, the price at the gas station is usually, the price is in dollars, but it's the cost per liter. So that is an example of a ratio. We're comparing the cost, which is the dollars, with the liters, which is how much you're putting in your tank. You can represent rates in several ways, and to compare them, you can either write them with the same units, or you can write them as something called a unit rate. And a unit rate is when one of the numbers in the ratio is 1. So for example, the cost of gas right now is, I don't know, I want to say something like $1.69 per liter. What this means is it is $1.69 for every 1 liter of gas that you put in your car. So that's the idea of a unit rate. We're going to see this other example looking here in example 1. So let's do that one. So example 1 says that orange juice is sold in 1.5 liter cartons and in 250 milliliter boxes. For a 1.5 liter carton, it sells for $3.75, and 10 250 milliliter boxes sell for $7.39. Which size costs less per milliliter? So what we're going to do is we're going to compare the rates of the two kinds of orange juice, and we're going to see which one is cheaper per milliliter. So whenever you see per something, that means that whatever's after that something is going to go on the bottom of your rate. And I'll show you what I mean. So we have the 1.5 liter costs $3.75. And we have 10 250 milliliter boxes sell for $7.39. Well, we have 10 times 250 milliliters. Altogether, that is 2,500 milliliters. And the cost of that is $7.39. Okay, so what we're going to compare is the cost of these ones with the cost of these ones. Now we can't go ahead and calculate it directly because whenever we want to compare two things, we need the units to be the same. But here, our unit is in milliliters, and here, it's in liters. So what we have to do is we're going to have to change this to milliliters, because that's what the question is asking here. So 1.5 liters, and to go from liters to milliliters, we're just going to multiply it by 1,000. When you do that, you get 1,500 milliliters. So now we have milliliters for this one, milliliters for this one. In terms of the cost, we have dollars and dollars, so we can go ahead and compare the two. Okay, so for option 1, remember we're looking for the cost per milliliter. That means we're going to take the cost, we're going to divide it by the number of milliliters. Okay, and when we do 3.75 divided by 1,500, so 3.75 divided by 1,500, we get 0.0025. So every milliliter costs basically a fraction of a penny. We're going to do the same thing for the second one. So the cost of the second one is $7.39. Divided by the number of milliliters is 2,500. 7 39 divided by 2,500 is 0.0029 blah blah blah. And that is the cost per milliliter. So which one is smaller? 0.0025, 0.0029. Clearly this one is smaller just by a little bit, but option 1 costs less by a very slim amount. It's very close. This is a good example of where you can use rates in the real world. Especially if you go shopping and you see that something is on sale, you can compare the cost versus the cost of a similar product to sort of figure out which one is cheaper. Decide which one you want to buy or not. Let's take a look at another example. So a world-class sprinter can run 100 meters in about 9.8 seconds, and we're going to figure out the speed as a unit rate in 4 different measurements. So the first one is meters per second. So all we do is we take our meters, we take our seconds, we divide the two. So 100 meters divided by 9.8 seconds. Plug that into your calculator. You get 10.2 meters per second. Second one says meters per minute. Well, we don't know how many minutes there are, so we have to convert this 9.8 seconds into minutes. Hopefully, you know that there are 60 minutes or 60 seconds in 1 minute. So what we're going to do is we're going to divide by 60 seconds. So we're going to do 9.8 divided by 60 is 0.163, and that's minutes. And now to find the unit rate, we're going to do 100 meters divided by 0.163 minutes. So 100 divided by 0.163 is 613.5 meters per minute. Again, just to come back to why this is a unit rate, because this is in 1 minute. So remember, our unit rate always has the number 1 on the bottom. This is 10.2 meters in 1 second. Okay, if we look at the next one, meters per hour, again, we don't know how many hours 9.8 seconds is, but if we just take our minute amount, and again, there are 60 minutes in 1 hour, so we're going to divide our 0.163 by 60. Oops, 0.163 divided by 0.163 divided by 60 is 0.00272. And that's hours. And now we're going to take that, we're going to do 100 divided by this 0.00272. And we get 36,764.7 meters ran in an hour. The last one is kilometers per hour. So now we already know how many hours 9.8 seconds is. Now we have to change meters to kilometers. There are a couple of ways you can do this. If you know how many kilometers 100 meters is, perfectly fine. Another way you can do it is say that 1 kilometer is 1,000 meters. So we're going to do 100 divided by 1,000, and we get 0.1 kilometers. So 100 meters is 0.1 kilometers. And again, we're going to do the unit rate. So we have 0.1 kilometers divided by 0.00272 hours. So 0.1 divided by 0.00272 is 36.76 kilometers per hour. So where do we see kilometers per hour in like our everyday life? I don't know if you pay attention to stuff like this, but all of our speed limits on the road are in kilometers per hour. So when you're like driving down Chalmers or whatever, the speed limit is 50 kilometers per hour. So this world-class sprinter can run 36.76 kilometers per hour, which is pretty insane, considering that somebody could be faster than a car. Pretty nuts. All right, we're going to take a look at a couple more examples. The first one says, Alexa is researching the fuel efficiency of 2 trucks. She found a website that advertised the hybrid truck with a fuel efficiency of 22 miles per gallon for highway driving, and another website that advertised the truck with a fuel efficiency of 10 kilometers per liter for highway driving. Which truck has the better fuel efficiency? So this first one is comparing miles and gallons. The second one is comparing kilometers and liters. So we're going to have to change one of them so that they match the units of the other one. Since we're in Canada, we use kilometers per liter, so I'm going to change 22 miles per gallon to kilometers per liter. Okay, so 22 miles per gallon. And it says here on the side that 1 mile is 1.6 kilometers. So what we're going to do is we're going to multiply by 1.6 kilometers for every mile. And then we are going to divide by liters. So 1 gallon is 3.785 liters. So we're going to do 22 times 1.6 divided by 3.785. The reason why I got these ratios is because see how my miles are on top of my fraction here? Well, to cancel it out and change it to kilometers, I need miles on the bottom of my sort of my conversion rate. Same thing here, I have gallons on the bottom, so I need gallons on top so that those cancel out as well. And when those cancel out, you can see that my units that I'm left with are kilometers on top and liters on the bottom, which is what I want. So I'm going to do 22 times 1.6 divided by 3.785. So 22 times 1.6 divided by 3.785, and you get 9.3. And this is 9.3 kilometers per liter. So the lower the number is, the better the fuel efficiency is. So this first truck here is lower than the 10 that was for the second truck. So truck 1 has the better fuel efficiency. All right, so if you have any questions about that, please let me know. We are going to take a look at one more example here. All right, so there's a little definition here, and hopefully you've seen this in grade 10. So hopefully it's a bit of a review. If not, just let me know. But we're going to talk about something called slope, and slope is the rate of change in one variable, usually y, compared to the other variable, which is x. And again, our slope, even though there's these minus signs, it's still written as a rate or a ratio. So we are going to draw a graph in example 4, and then we are going to check out the slope of each of our lines. So example 4 says To draw a graph representing hiking 500 meters from a campground in 10 minutes, stopping for 5 minutes, then hiking another 400 meters away from the campground in 8 minutes, and then hiking back to the campground, basically back the way you came, in 15 minutes. Assume you're traveling at a constant rate for each part of the trip. Over which interval is the hiker traveling the fastest? Alright, so I'm going to make my graph. I'm just going to call this 0 here in the corner. I'm going to put my time along the bottom and my distance along the top. And the reason why I do that is because time is usually an independent variable, and independent variables go on the bottom, and the distance is my dependent variable, which always goes on the side. So I'm just going to maybe count up by 5 for every 2 lines. We'll see how much room I have for that. Perfect, just enough, I think. And then here, we'll go up by 100 meters each time. Hopefully I have enough room for this. I don't think I'm going to have enough room, but that's fine. Maybe I'll just do every line then. 2, 3, 4, 5, 6, 7, 8, 9, and I don't think we need any of these. Sorry, that looks really terrible, but basically I counted each line here up 100 meters. So this is my distance in meters, and this is my time in minutes. All right, so we're going to start at the beginning. So after 0 time, we've gone 0 meters. It says we've hiked 500 meters from the campground in 10 minutes. So at 10 minutes, we are going to be up here at 500 meters. And we'll just draw a line connecting that. Then it says we stopped for 5 minutes. So if we're stopped, our distance hasn't changed at all. So we're still 500 meters away for those 5 minutes. Then it says we hiked another 400 meters away from the campground over 8 minutes. So 8 minutes would bring us somewhere around here. So between 20 and 25. And we went up another 400 meters. So we would be at 900. So somewhere right there. And again, we can connect those lines. And then we hiked back to the campground along the same trail over 15 minutes. So we're going to go back down to 0. And if we add up all the time, let's just see where we should put it. So the total time was 10 plus 5 plus 8 plus 15, which I believe adds up to 38. So I'm going to put a point here at 38, and we're back down to 0 because we're back at the campground. So something that looks like that. So I'm going to say this is the distance from the campground. All right, so the question says, over which interval is the hiker traveling the fastest? So basically, for each of these 4 lines that we drew, we are going to calculate the slope. And whichever slope is the highest, that means that that was the interval that they were traveling the fastest. Okay, so I'm going to call this 1, 2, 3, and 4. Okay, so for slope 1, remember, slope is y2 minus y1 divided by x2 minus x1. So our y2 is where we ended up, which is 500, minus our y1 is where we started, so 0, divided by x2. X is our number along the bottom, so that would be 10, minus our starting point, which is 0. 500 minus 0 is 500. 10 minus 0 is 10. 500 divided by 10 is 50. So this would be 50 meters per minute. For slope 2, again, our y is the distance. So here's 500, here is 500. So because we haven't gone anywhere, we're just stopped basically. And then our time, we ended at 15, we started at 10, so 15 take away 10. And this is just 0 divided by 5, which is 0. Which makes sense because we would get a slope of 0 because we didn't go anywhere. So we didn't move, we didn't travel at all. Slope 3, we hiked 400 meters over 8 minutes. So I'm just going to go a little bit faster here. We can just do 400 divided by 8, which again is 50. So we were traveling 50 meters per minute. And then slope 4, we traveled 900 meters over 15 minutes. And 900 divided by 15 is 60. So coming back, they traveled 60 meters per minute. So over which interval did they travel the fastest? I guess we can call it interval 4, which was the trip home. Okay, so if you have any questions about any of this, please let me know. And yeah, try some of the homework questions, and I'll put up another video for the next lesson shortly.